Hey guys, have you seen this before? It says the limit as x goes to 0 of a to the power of x plus b raised to the power of x plus c to the x all over 3 all raised to the power of 1 over x. This is an interesting question and you will love to see how it was solved. So I would love to bring down my 1 over x because I can't put in the 0. I can't put in the 0 here. If I should, then this is 1 over 0, which is indeterminate. So I would love to bring down my 1 over x. The only way I can do that is to make the whole of this limit equal to something. I call that thing k. So k is equal to the limit as x approaches 0 of a to the x plus b to the x plus c to the x all over 3 raised to the power 1 over x. The only reason I did this is to log both sides, and you know when you log this whole thing, you can easily bring this down to the back of the logarithm. So let us take the natural logarithm of both sides. So ln k is equal to in bracket limit as x approaches 0 of a to the x plus b to the x plus c to the x all over 3 raised to the power 1 over x. So limit allows us to do this. We can take in the logarithm inside the limit. Limit allows us to do that. It becomes the natural logarithm of k equals to the limit as x approaches 0 of ln a to the x plus b to the x plus c to the x over 3 raised to 1 over x. So this is beautiful now. So we can take this down, and when we do that, we say ln k is equals to the limit as x approaches 0 of 1 over x into brackets ln a to the x plus b to the x plus c to the x all over 3. So how can we solve this now? We can substitute the 0 as x inside the whole of this because the limit goes to 0. So if we do that, 1 over 0, that is undefined. Fine, we still have an undefined character here, but we can actually simplify the one in the bracket into something nice. We say ln k is equal to the limit as x approaches 0 of 1 over x into bracket ln a to the x plus b to the x plus c to the x minus ln 3. So this is possible according to logarithm. When the input divides themselves, you can split it like this with a subtraction sign. So if that is so, I can multiply the whole of this with 1 over x, and it becomes k equals to the limit as x approaches 0 of ln a raised to x plus b to x plus c to x minus ln 3 all over x. So now we can now substitute the 0 to this. If we do a to that is 1, b to the 0 1, this is 1 plus 1, that is 2. So we have ln 3 minus, so ln 3 minus ln 3, that is 0 over 0. Whenever we have the 0 over 0 situation in limits, we are allowed to use what is called the L'Hopital's rule. The L'Hopital's rule allows us to differentiate the top and the bottom separately. So we do that, and if we do that, we have the limit, we have ln k rather is equal to the limit as x approaches 0 of, by differentiating the top, we would have something like this. Differentiate this separately. If we differentiate the constant, we have 0. If we differentiate this, we would have something like this. The input, 1 over the input, 1 over a to the x plus b to the x plus c to the x. This method I'm using is called the chain rule. So we make this whole thing equals to some value. So let's just put in here that this is k. So ln this is p. So ln p, since we already had k. So ln p, when you differentiate ln p, you have 1 over p, right? So that is 1 over this stuff here. But according to chain rule, we multiply by the differentiation of the input as well. So differentiating this, we would have a to the x ln A plus b to the x ln b plus c to the x ln c. You do that in your own time. So this is what we got, and the denominator differentiating x, we have 1. So this is 0 already, so we don't need to write it, and this is 1, we also don't need to write it. So now we say this is natural logarithm of k equals to the limit as x goes to 0 of this. The limit as x goes to 0 of this. Now we can substitute our 0 into all of this. So if we do so, we have that a to the 0, b to the 0 plus c to the 0, that is 1, 1, that is 1, 1, 1, that is 1 over 3. So we have 1 over 3 multiplied by a to the 0, 1, multiplied by ln a, that is just ln a. This as well is just ln b, and this is just ln c. So we have from this, we have ln a plus ln b plus ln c over 3. So this is our ln k. But we were initially asked from the beginning to look for this. And we already know that this is equal to k. According to what we made it to be. We made it to be k. So this is equal to k. So we are to find k and not ln k. The only way we can actually find k from this is to say e raised to the power of this, because when you raise this to the power of e, it cancels out the natural logarithm. So we say e to the power of ln k equals e to the power of ln. This can be written as ABC. We multiply them because they add each other. That is a rule of logarithm. So over 3. So now these cancel out this smoothly, and we are left with k to be equal to 1, to be equal to e raised to the power of 1 over 3 times ln ABC. 1 over 3 times ln ABC. According to logarithm, we can take this at the back of it to the power. And when we do so, we have k to be equal to e to the ln ABC to the power of 1 over 3. So this as well cancel out this ln, and we are left with k equals to ABC to the power of 1 over 3, which I can rewrite as the cube root of ABC. So this is our final answer to the question. When the limit as x approaches 0 of this, we got the cube root of ABC as the answer.